So I would like to welcome everybody to the Partisia Blockchain Foundation Community AMA, the first one that we're doing here in 2022. Mark your calendars. We will have another one next month, and we're probably going to be doing these every single month. So thank you to everybody joining us from around the world, and a big shout out to all of you who either submitted questions or voted on your the questions that you like the best. And we will be answering all of those questions for you today during our call. And without further ado, I would like to hand over the presentation mode to our co-founder, Kurt Nielsen, who will start. Then we will have Peter giving a speech about the technology side, Peter, our CTO. And then we will have Brian Gallagher talk more about developments in the marketing space and partnership space. All right, so let's get started.
Excellent, thank you. I will start sharing the screen. Yeah, so 2 seconds. There we go. Yeah, welcome everyone. And I'll give a short introduction to the project. So this is the agenda with a few words about the infrastructure, and then Peter will come in and talk about the software development, and Brian will give us some examples of applications that we are working on, and we'll do the AMA, all your questions, and thank you for them. So let's jump right in. So the story about Partisia is really the story about MPC and blockchain, and the whole project is about merging these two technologies. And one way to understand that history is actually to look at the team. So if you start from the top, we have Ivan Danko, who's well known in crypto or in cryptography for many years, not least due to his early results in the 80s. One is the Merkle-Danko hash function, which is basically in all of blockchains today. And we also have on the other side, on the MPC side, some of the foundation for this technology, for the MPC multi-party computation. And then based on that, the rest of the team sort of dropped into this project. So I was in there in the early 2000s, and we started to raise funding for developing these and bringing this technology out of academia and into real life use. And that's what this story is all about. And now we're building this, merging this with blockchain technologies. So if a little more flavor to that story, we can put it into 4 different phases. So the first phase was the creation of the basic or the foundation, and then we have the second phase, which is fundraising for research, and also for research that move this out of the university and into real life use. So that we started in 2004. This has been going on ever since. So it's more than 20 different projects that have been raised around 100 million US in total budget altogether. So it's significant effort, and it's resulted in the first real life use of this technology in 2008. And that was also the beginning of phase 3, where we established Partisia, which is has been the pioneer for this technology and bring that into commercial use. And interesting enough is that it's only a short time before the establishment or the release of the Bitcoin protocols. So they were there in the market at the same time. And in the beginning, we focused a lot on bringing this into auction solutions and solving basically replacing the auctioneer in a sealed bid auctions. And along that way, we discovered the use case of key management, which turned out to be one of the first large scale uses of MPC. And we all know that. So today we see companies like Coinbase and PayPal that is buying into this technology. And at the same time, in this period, there was a significant improvement of the technology, and most prominent, we saw an improvement of that the speed of these protocols, not the hardware, but the protocols, became 1 million times faster. A significant improvement, and the team behind the Partisia has been a large part of this work. Then we get to phase 4, which is where we start merging this technology with blockchain. And we had Brian's team coming in as approaching us. And at the same time, we had a team that is working on financial order matching. So in parallel, we worked on merging MPC for two use cases on data exchange and financial order matching. And that was the foundation for creating this infrastructure that today is Partisia Blockchain. So the first step was in 2019, where we had the private deployment version that was licensed to customers, and today we are ready to launch the public version of this network. So we have more people coming in as we sort of move forward on this journey. I think one important thing, so today there's a lot of people involved in this. There's been a separate and parallel involvement in the academia and represented most prominent by Ivan, Jesper, and Claudio as co-founder here at Aarhus University, where the cryptographic group, the crypto group, is located. So here you can see a few pictures, and you can see how this group actually grow in parallel in this period. So this is also important for us since they are educating continuously new experts in this technology that we can hire, and it's super important. And this people is the limited resource in this industry. And we have the perfect source of this. So that's the current team and story behind Partisia. So, but we keep extending the team. So we just hired Jennifer. Welcome, Jennifer, as a communication director. And we next is a CMO and a COO. And we have some very impressive resumes that we are reviewing at the moment. So we're really looking forward to announcing these two positions soon. So with that, I will jump into talking a bit about the technology, the network, and the value added that we bring to blockchain. So this is an illustration of how we contribute with privacy to blockchain. So blockchain itself sort of replaced the need for a trusted coordinator in the economy. So you have an immutable ledger. So that's great for representing transactions. But for many applications, you will also need to control the information, and we'll get back to that, and also the use cases that we'll present at the end. Emphasize how privacy is actually enabling a lot of new applications. And that's exactly what we're doing. So we're bringing in this software version of a distributed solution to privacy that matches the blockchain. And we use the blockchain as a way to orchestrate and run MPC. So it's a great match. It's absolutely destined to be merged at some point, these two technology. I'll move you down here for a minute. So one of the market and the value added, one of the basic market is the so-called Web 3.0. And this is all about making users, creating a user-centric internet. So the next version of the internet that is giving back power to the individual users. And in our mind, and I believe this is absolutely true, this can only happen if you go in and control the data itself. Without a distributed system on its own, doesn't allocate the real power back to the individual, but privacy does. And that's exactly what we do here. We bring in distributed and decentralized control and privacy to the next generation of the internet, and that would basically gives us a strong position, we believe, for this future market where the internet is going to include many more services within banking. We know already that, and insurance and healthcare and many others. This is where we are focusing our attention. So So now the next slide is a quick introduction to the network, to the Partisia blockchain as a network. So this is first an overall view of the token economy. So we are creating this MPC token that you can buy, and you can use that to stake a node, and then you can operate a part of the network. And here you have the one of the differentiator that we bring to the market, which is a decoupled token economy, where you as a node operator, you're paid with liquid external coins. So they are funneled back to the node operators when they do operate the network. Along the way, we are building all kinds of additional services such that anyone can bring their token to work basically in this economy, from mini nodes that is contributing to the privacy part and the storage, to market where you allocate or move your tokens into the hands of node operators and earn a rent in that way. This picture is sort of capturing the technology stack. So here we have, it's pretty much like any blockchain, except that we have here a private and a public and a private smart contract layer. And that's also a very big differentiator. So this is where you have the developers coming in and orchestrating privacy preserving computation through a smart contract language. So it's also both a layer 1 and a layer 2, and they bring your own coin, which was on the previous slide where you had this decoupled token economy. We can offer our services to other blockchain, and they can bring their coins to work on our network, and that sort of provide that basic trade-off that positioning us to tap into existing network and collaborate with all the existing blockchains out there in the industry. So the network as such is divided, and the service is divided into two. We have the basic blockchain service, consensus and governance, and then we have these specialized services on top of that. So that's the zero knowledge computation, that is to bring your own coin, and it's token bridges, and more is coming. So if I just give a quick rundown on these three things that we're doing, they come with so that also gives us different node operator roles. I guess you can put it that way. So we have the Baker nodes, which is running the basic blockchain, creating consensus. We have the CK nodes, and we have running zero knowledge computation, and we have the Oracle nodes that is running the bridging and the interoperability. So let's just have a quick view of that. So the Baker node, that was all about the consensus. So what is also new here is that we are actually creating a new blockchain that builds on best practice from the existing network. So it's an ecosystem. So we manage a high throughput of transaction. And we also have a scalability built in the form of sharding. So when we meet the boundaries of the system, we can add a new shard, and instead of adding a market that prioritizes transactions, as you know it from Ethereum, where you have the mempool market, where the prices is prioritizing the transactions that goes into the block. Here we are removing congestion by adding shards. Very big differentiator. The next part here contains tons of information. So this is all about orchestrating zero knowledge computation and multi-party computation. So a lot of things can be said about this. You have to allocate resources for pre-processing. You have to allocate resources for real-time operations. And but first of all, the project is about doing this in a very efficient way. The second part is to make that very simple to use for developers. And that's the smart contract language, the private smart contract language that would allow developers to go in and use all the tricks in the book for how to make MPC run fast and smooth. without really knowing much about the underlying technology. The last part is the Oracle nodes, and that is the bridging. And this is clearly a critical thing. This is where you have the most security breaches out there in the industry. So this is where you're moving tokens out of one security model to another. So we really have to think hard when we do that. So we have basically 3 measures to manage this. So one approach is a double bookkeeping system, which is that we're creating transparency about the state on the 2 different blockchains. So you can see that it matches what's happening on one blockchain. It's also happening on the other. The second one is to allocate the oracle that operate these bridges, and that is about creating signing material. And this is done by MPC, and it's not done by a small group of nodes. It's actually done by the entire network. So this is where hundreds of nodes is running MPC and creating signing material. So we are actually bringing the security level up to the highest stage in the network, the same stage as the consensus protocol. The third element is the staking. So the node that is running the bridge is a smaller group, but they only run the bridge in a smaller time period, an epoch. And within that epoch, they stake the values that is moved across the bridge. And there is a dispute process built into the solution, and that's enable. If something goes wrong, there will be an opportunity to run a dispute and get your reclaim the losses. So that's the 3 roles: the Vega, the CK, and the Oracle nodes. So here at the end, I just want to give you the first sort of example of how we are differentiating ourselves to some other networks out there. We will extend the work and compare ourselves to the industry even more when we move forward. So, but I want to emphasize 4 things. One is the rapid block creation. And here the finalization is important. It's very difficult to find numbers on other blockchain on what is the actual finalization. So our finalizations happens almost immediately after the block creation. So it's almost these 0.3 or 0.4 seconds. That's definitely a differentiator. The second one is the scalability, the sharding. So that means that the TPS is basically a number that we can set arbitrary to the use of the network, as explained earlier. The third one is clearly generic privacy. So this is the big differentiator where we come in with this second half to the entire industry of the ability to not just do small, simple, zero knowledge proof type of computation, but do generic computation on private data. So you can actually do sophisticated matching of data and find the right matching financial order, or the patients and the doctors, or whatever you need to match out there in the economy. The fourth thing is the bridging, which is the interoperability, which is native to the blockchain. So that is the Oracle nodes that is running this part of the network. So I think with that, I'm at the end of my part. So Peter, take it from here.
Yes. So I would like to talk about the team. So Kurt talked quite a bit about how the team has developed over the last 40 years, but I would like to talk about how that we're working with the team now. We currently have more than 25 software developers. What we are looking for in our software development process is we're looking for qualified and experienced software developers, because we're developing core level protocol type of software that really needs to work. So what we've hired for people with a lot of experience. So we not only do we have experience in terms of a lot of software development experience, but we also have extensive managerial experience. We have strong focus on delivering this very core technology that cannot be allowed to break. So that's why we are using 6 different static analysis tools, and we are actually requiring that our software meets a very high level of scrutiny in order to be correct and in order to be able to be executed in a sound way. This also means that once we got into the process which we have completed, where we have had our core services reviewed by an external company, we had some very solid findings. So they looked at our two different parts. They looked at our part where of our core blockchain service, which is basically the protocol layer. This is where the things is happening. This is where we create blocks, and this is where we include transactions, and this is where we execute these different changes to the state. And this ends up in being, this is, if there are failures here, this will be able to break the entire network. That they looked through that code. They also looked through the economical part, the parts that Kurt just covered, where we have the MPC tokens and the bring your own coin token. All of these parts were reviewed by Casaba, and they found 11 issues in total. And not to brag, but that's a low number. That's a very low number. We've looked at all these issues, and all of them have been fixed, and we've gotten a clean report. And I've included some of the things that Casaba wrote about us, and you can see in the slide here that they actually were quite they found that our code was at a very high quality level and was ready for the next level of development. So the code that we have right now is looking good, but the code that we are going to write is not written yet. That's the idea of not having. And that brings me to the roadmap. What are we going to do in the future? And there's so many things on this map. So you can see the roadmap here spans multiple years and has a number of different things that needs to be addressed. We are getting ready to do the mainnet launch, and that's the core focus for us right now. A lot of the things that are going to go into the mainnet has been done and is completed. So it means that my focus now will be, our focus on the development team is going to be what's going to happen in June. So what's going to happen with the next major release, the version 3.0. And the biggest thing, the one that there are so many good things, and it's hard to sort of go into all the details of everything. But the biggest thing that we're going to do is actually the first time in the history of MPC and in the history of blockchain where we are combining, where we are building our own smart contract language. So this is some of the things that I'm really proud of, that we as a team are achieving, that we are actually for the first time doing something that hasn't been done before, where we are combining the need for doing public smart contract with the need for doing privacy computations. And this first version of that language is going to be released this summer. And once we have that, we have something that nobody else has had before. There's been some efforts in both in research and in practicality. Some of it has started in blockchain space, some of it has started in the zero knowledge computation in the MPC space, but you have to design for that from the bottom up if you want to have a smart contract language that comprises both things in a proper way. And that's going to happen. And then we are also, and the other things that we're also going to do, and I'm not going into too much detail, the other things that we're going to do is that we're going to take the Bring Your Own Coin Oracle, which is already available on mainnet beta, and we're going to extend that. We're going to make that not only a single service for Ethereum, but it's going to be something that everybody can use to create more different types of oracles and different types of Bring Your Own Coin in their own versions, and that's so we're going to extend it as a generic framework. But we're not going to stop there. We are also going to look into extending that Bring Your Own Coin to a token bridge. So Bring Your Own Coin maps to blockchain, one of them being the PPC blockchain, and token bridge now the bridges to a third blockchain. So you can actually move valuable assets from any blockchain to any other blockchain using the generic framework that the token bridge supports. And all of this is being done while we are adhering to the same security model that Kurt presented earlier, where we are doing the double bookkeeping and where we are using the stakes of the entire blockchain to actually support the valuables that are being transferred around. And then we are also going to work on extending the zero knowledge functionality with more dynamic representations and agile swapping of different types of representation. and establishing microprocessors. All of these, we're probably going to have more time to go into more details of in the next coming months. So I'll leave them that for now. But you should have a look at the roadmap. The roadmap is not only is it impressive, it's also, from my perspective, quite ambitious. And with that, I think I'll leave it, and we'll move over to Brian.
Thanks, everyone. Now let's turn the floor over to Brian. And to watch Brian's video, please click on the very next video in YouTube if you're watching this on YouTube. Thanks, everyone. Bye.
Bye-bye. All right.
Yep, that was all right for me.